Okay, in this video we're going to learn how to solve linear equations. Here's an example of a linear equation, y equals 2x plus 3. Okay, to solve a linear equation means to isolate or get by itself the unknown. Isolate the unknown. Now in this case we already have isolated one of the unknowns, y. Y is on its own here, but usually it'll be rearranging the equation to isolate the other unknown, the one that's not on its own at that moment. So in this case x. Isolate the unknown, and we'll put x in brackets for this one. That's the unknown that we're trying to isolate. Okay, so isolate means to get by itself. We've got to get the x by itself. So we want to end up with something like this. X equals blah 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 blah. There'll be something on the other side. Okay, so we need to rearrange this equation to make it look like this one. Okay, how do we do that? We need to do reverse operations. Reverse operations. Here's what that means. Okay, around this x are a bunch of operations. There's a plus 3 and there's a times 2. And sometimes there'll be lots of other operations around the x. Okay, to do reverse operations means to do the opposite of whatever those operations are. This operation here, this plus 3, says take x and add 3 to it. And the reverse operation of add 3 is obviously minus 3. Okay, so we'd have to get rid of this 3, we'd have to do minus 3. And when we have plus 3 and minus 3, that adds up to 0. And we don't write 0, we just cross it out. This operation here is 2 times x. The reverse operation of 2 times x is, if you've got x and you multiply it by 2, the reverse is to divide by 2. Okay, when you have 2 divided by 2, that equals 1. 2 divided by 2 equals 1. So we can just replace this with 1, and then we've just got 1x, which is just x. So in other words, the 2's disappear. So that's what we mean by reverse operations. And the reason we're doing it is to isolate the unknown. We want to get rid of these operations that are around the x so that it's on its own. But it's very important, whatever operations we do, if we minus 3 here, then to keep the equation balanced we have to do it over here as well. If we divide 2 here, we have to do that over here as well. Okay, so that's the second thing to know. To solve linear equations, we need to do reverse operations. Now, let me just clean this up a little bit so that we can see what we're doing again and write out the equation again. Y equals 2x plus 3. Okay, now the question arises, if I've got to do, I know I've got to do minus 3 and divide by 2, but which order do I do it in? How do I know which one to do first? Because it's going to change the result, the order that you do it in. Okay, the answer is in order of reverse BODMAS. In order of reverse BODMAS. Okay, we do the reverse operations in order of reverse BODMAS. So BODMAS is what tells us what order to do operations in. If I actually had 3 plus 4 times 5, then I've got a dilemma. Do I do 3 plus 4 and then times 5, or do I do 4 times 5 and then add 3? Okay, the order makes a difference. And BODMAS tells us what order to do it in. It says do the multiplication first, then do the addition. So that's what I'd do for BODMAS. But here, that's for doing normal operations. But in solving this linear equation, I'm doing reverse operations. I'm doing the opposite. Okay, so you can understand why BODMAS gets used in reverse now. So looking at this equation, I've got to do the addition or subtraction reverse operations first. So that means I'm going to do minus 3 first. Addition, subtraction, do this one first. Do it on both sides. And after you do each operation, it's very important to rewrite the equation. So I'm going to rewrite this equation now. Y minus 3 is on that side. That's gone on that side. So now I'm just left with equals 2x. Okay, and I'll just move this out of the way. In fact, I'll just delete it and put that under there. Okay, now we've rewritten the equation. The next step we said was to divide by 2. The 2's cancel out, and we've got to do the same on the other side. So we end up with x equals, x is on its own now, x equals y minus 3 over 2. Now you could write that as y over 2 minus 3 over 2, but this is probably a better way to do it. This just shows you though that what you've actually got is y divided by 2 and then minus some number, whereas this, you know, maybe doesn't show that as clearly, but that's a better way of putting it. Okay, so that's how we solve linear equations in general. Now let's look at a few specific cases where things get a little bit trickier. That's the basic rules, but sometimes we need to know a couple of other ways around certain problems. Okay, well first just solve a couple of quick and easy ones to make sure we've got the hang of it. So for this one here, I've got to do the plus 3 first on both sides and rewrite it. They cancel out, and now I've got 2x equals 4 plus 3 is 7. Then I'll divide both sides by 2, and I'll get x equals 7 over 2. Okay, and then in this one, I've got x divided by 6, and I've got plus 2. Reverse BODMAS, we should write BODMAS over here so we don't forget. Reverse BODMAS says addition subtraction first, so I'm going to do minus 2 first on both sides. That cancels out. X over 6 equals 8 minus 2 is 6. And then times 6 here, times 6 here. The opposite of divide by 6 is times by 6. X equals 36. Okay, for this one, let's get rid of the 10 first. So minus 10 on both sides. That's cancelled out. Minus 3x over 2 equals 5 minus 10. If I had a number line, here's 0 and here's 5, and then I go minus 10, that's minus is going backwards, and minus 10 is going to take me 5, and then another 5, I'm going to end up at negative 5. Okay, then I want to get rid of this divide by 2, do times 2. Now notice I had here a multiplication and a division. It doesn't matter what order you do them in. Once you get into the DM territory here, it doesn't matter the order. The same with addition subtraction. You could do an addition then a subtraction, or a division. So you could do an addition then a subtraction, or the other way around. It wouldn't change the result. So if we had done divide by 3, which it wouldn't have made a difference. Negative 5 times 2 is negative 10, and then divide by, actually we wouldn't have divided by 3, we would have divided by negative 3. Divide by negative 3 on both sides, and we get x equals, the negatives cancel out, so we've just got 3 and 1/3. Or I could have just left it as 10 over 3. That's fine too. Now notice the steps that we're going through here. We write out the equation. We make a change to both sides. Then we rewrite the equation. Then we make another change. We rewrite the equation, make another change, and so on. So those are the steps you need to follow. If you try and divert from that, try and skip steps, don't write things down, that's when you make mistakes. Okay, very important to write all your steps down. Okay, in this equation that we want to solve for x again, we've got a different difficulty. We've got x on both sides of the equation. Okay, now that's a problem because we want in our answer to just have x equals and a bunch of numbers over here. Okay, that's no good to us. To have x on both sides, we need to have x on one side. So very simply, what we're going to do is just minus x from one side. Get rid of the x's on one side of the equation. It doesn't matter which side you do it to. You could have easily done minus 4x over here. Doesn't matter. So it'll end up the same. So when we do that, 2x minus 2x equals 0. That's gone now. We've got to do it to both sides though. Okay, so now we rewrite the equation. Negative 4 equals 4x minus 2x is 2x, and then plus 6. Okay, and from here, it's a pretty standard equation. Plus 6 minus 6 cancels, minus 6, that gives us minus 10 equals 2x, divide by 2, and we end up with x equals negative 10 divided by 2 is negative 5. Okay, so when you get x on both sides, you've just got to take away the x from one side or the other. Or if you had negative 2x equals plus 4x, then you could get rid of that by adding 2x. That would make that disappear, and you get 4x over there. So plus 2x, you get 6x over this side, and you'd have 0 over here. Okay, so you just need to make sure you've only got the x's on one side of the equation. Okay, here's another problem of a slightly different kind. The difficulty with this problem is that we've got these brackets here, okay, and they kind of interfere with our reverse operations. Because normally when we look at an equation like this, we want to solve it. We want to get rid of the pluses and the minuses first. We want to look at this and we want to go minus 5. But because of these brackets, that's not going to work. If you take away minus 5 from both sides of this equation, that plus 5 there, it's not going to disappear. You're just going to get this. 2x plus 5 minus 5. Okay, it's not going to get rid of this plus 5. What we need to do is to get rid of these brackets. We need to get rid of the brackets first. The best way to do it is to just expand the brackets out. Expand the brackets out, multiply the outside by the inside, so we get 2 times x is 2x, and 2 times 5 is 10, plus 10. Over here we get 3 times 2x is 6x, and 3 times negative 6 is negative 18. Okay, now that we've expanded the brackets out, we can proceed as we normally would. We'll get rid of the x's on one side. Then we've got 10 equals 6 minus 2 is 4x, minus 18, plus 18. We end up with 28 equals 4x, and then 28 equals 4x, divide by 4, and we get x equals 7. Okay, for the other one, we've got 4 brackets 6 plus 2x, and then equals 20. Again, let's expand the bracket out. Let's get rid of the brackets. 4 times 6 is 24. 4 times 2x is 8x. And that all equals 20. Then minus 24, minus 24. That cancels out. And we've got 8x equals 20 minus 24 is negative 4. Divide by 8. Divide by 8. X equals negative 1/2. Another option here, that's a fine way to solve that. Expand the brackets out. If you're not sure what to do, just do that. But another way you could have solved it, if we go back, if we had divided this side by 4, then that 4 would have cancelled out that 4. And if we did the same on the other side, then we'd find we would have had 6 plus 2x equals 20 divided by 4 is 5. And we could have solved it from there as well. But if you find that a bit confusing, just stick with expanding the brackets out and then solving as normal. Okay, here's another kind of problem. In this one we've got these fractions within the equation. And the tricky thing about fractions is that there isn't going to be one thing we can multiply them all by that will get rid of them. Okay, let's say we wanted to get rid of this x. Whatever we do to this x, it's going to affect this x over here and just change it around. Okay, it's not gonna work. So what we want to do is to try and get rid of these fractions if we can. If we can find a way to get rid of them, it'll be much better. Okay, the best way to get rid of them is to look at these denominators on these fractions and say, what's the lowest common denominator? The LCD. Okay, another way of thinking of it is it's the lowest common multiple, and it just happens to be a denominator. So the lowest common multiple for 2 and 3 is 6. Okay, the smallest number that's a multiple of both 2 and 3 is 6. That means we want to rewrite these equations, these fractions rather, with 6 as the denominator for each one. So we'll put 6 on the bottom of each fraction. Okay, and what we want to ask ourselves is, how do we get from this to this? Okay, we want to end up with an equation that looks like this with 6 on the bottom of each of these fractions, so that's our common denominator. Alright, now it's pretty easy. All we've got to do is say, how do we get from 3 to 6? What's a factor we can multiply it by to get from 3 to 6? And the answer, of course, is 2. You multiply 3 by 2 and you get 6. Whatever we do to the bottom of this fraction, we're going to have to do it to the top as well. We're going to have to treat it, we're going to have to pretend like we're multiplying this thing by another fraction that's the same top and bottom. Because if we multiply something by the same top and bottom, 2 over 2, 2 over 2 equals 1. So we're just multiplying it by 1. We're not really changing it. Okay, we're just making it look a bit different. So let's do that. Let's multiply the top by 2, and we get 2x plus 2. Okay, I've multiplied this whole thing on top by 2. Let's go over here. Now this doesn't look like a fraction, but it is really. 5 is the same as 5 over 1. It's a fraction. How do you get 1 to become 6? You multiply it by 6. If that's what I've done to the bottom, that's what I'll do to the top. So that's going to become 30 over 6. This last bit here, we've got x over 2. To get 2 to become 6, you multiply it by 3. So we'll do the same to the top, and we'll get 3x. Okay, there we go. Now we've got common denominators in our equation, so we can do this very, very easily. If we multiply everything by 6 now, then all these fractions disappear. Okay, this is just an example of our reverse operations. We've got divide by 6, so we multiply by 6. And that way all of the fractions disappear and we end up with this. 2x plus 2 equals 30 minus 3x. Okay, and from here you can solve it as a normal linear equation. So we just expand this bracket out. 2x plus 4 equals 30 minus 3x. We'll get rid of this 3x over here, plus 3x over there. 5x equals 4, or 5x plus 4 equals 30, minus 4, minus 4. 5x equals 26, and then divide both sides by 5. X equals 26 over 5. Okay, so the trick is, with these fractions, these linear equations that have fractions in them, when you see fractions, you've got to change them to equivalent fractions, like we did here. Change them to equivalent fractions that have the same denominator. Okay, and to choose what denominator, the lowest common denominator. That's what you look for. That's what you try and create. Once you've done that, once you've got the same denominator on each fraction, then the denominators disappear and you've got a nice simple equation to solve then. Okay, hope you enjoyed the video. Here's a couple of notes to finish off and you can copy those down, and thanks very much for watching.